Hello, welcome back. Today we're going to start taking a look at the 2021 BC Calculus exam. And this is going to be question number 1. And they give us a table, so most likely maybe a Riemann sum or a trapezoid will be here. And question number 1 talks about the density of bacteria in density of a bacteria population in a circular petri dish from a distance r from the center of the dish. Now, it is an increasing and differentiable function, so we'll probably be using that information later on, where FR is measured milligrams per square centimeter. So it looks like the further we get out from the center, the more densely packed the bacteria is. And they give us selected values for the density over a certain domain there. So for question A, it says, use the data in the table to estimate f prime of 2.25. So I don't really have a value there, but I know 2.25 is between 2 and 5.5. So this is just our average rate of change formula. So that's going to be here, it's going to be f of 2.5 minus f of 2 over 2.5 minus 2. And that's, of course, is going to be 10 minus 6 over, that's just 0.5, or 4 over 0.5, which is just 8. Now the units on this one, it's going to be, well, on top we have milligrams per square centimeter, so we have milligrams per square centimeter over, and on the bottom, centimeters. So what does this tell us? Well, they do ask us to interpret the meaning of this, and of course this is just going to be when the distance is 2.25 centimeters from the center, the density, this is a rate of change, is increasing at a rate of 8 milligrams per centimeter squared per centimeter. And that would be our unit. Don't make that centimeter cubed, that would be a little bit different of an answer. Now this is coming up before the scoring guidelines, so I really couldn't tell you how much these are going to be worth in points wise, but that's how they would answer. Most likely 2 points, 1 for your answer, 1 for your answer with your justification. Alright, B is kind of a tricky one right here. It says the total mass in milligrams in bacteria in a petri dish is given by the integral expression 2 pi 0 to 4 of r f of r. Approximate this value using a right Riemann sum. Of course, there it is, the Riemann sum indicated with the data indicated in the table. But notice it's not just a Riemann sum of r times f of r. It's this distance right here. So my length of my rectangle will be r d f of r, and this would be, of course, my height of my rectangle. So what we need is this r f of r, and I'm going to use this table for that. R times f of r. Of course, over here, r times f of r, so 0 times 1 is 0. R times f of r is 2 here. 2 times 6 is 12. And of course, this is 25. And 8 times 4 is 72. So that's our f of r, f of r. So when I graph it, if you think about the y-axis as being r times f of r, and of course your x-axis, whoops, let me go a little bit further than this, as being r, we go 0, 1, 2, 2.5, and 4. Now we're using a right Riemann sum, so between 0 and 1, of course, between 0 and 1, 1 is on the right side, so it's going to give us a height of 2. Between 1 and 2, 2 is on the right, and that's going to give me my height of 12. Remember, we're looking at r times f of r, not the 6. So this is going to give us a height of, whoops, 12 right there. And if we go to the next one, between 2 and 2.5, 2.5 is on the right, that's going to give me a height of 25. And then the last one, 4 is on the right, which is giving me a height of 18. Right, so. And now, when I want to evaluate this integral, this 2 pi from 0 to 4, r f of r dr, this is going to be approximately 2 pi times, using your rectangles, this is 1 by 2, so it's 1 times 2 plus 1 by 12 plus, this is 2.5 by 25, and the last one, that's 1.5 by 18. Use parentheses there so I don't confuse the dots with multiplication. And let's talk about the units here if you want to. Let's talk about units. Ready? R, f of r, dr. Well, r, of course, is measured in centimeters. Fr is going to be, this is my unit right here. This is milligrams per square centimeter. And this, of course, is centimeters as well. And, of course, all those units cancel. So we're left with just milligrams. Don't worry about simplifying it, but if you did, you would get whoops, let me go to approximately. You would get approximately 845.088 if you type that in your calculator right there. All right, so let's see here. All right, part C, it says, is our approximation an overestimate or an underestimate? So this is what we're talking about, mainly concavity for the most part, but we should remember, like, let's say here, we look at our function. I know this is an increasing function, and we're taking a right Riemann sum. So I'm going to start off by saying that since r, f of r, is an increasing function, and we use a right-hand sum, our approximation will be I'm just going to write this down. Our approximation will be well, I forget what it is, so I'm going to draw something out here. Just help me out here. A decreasing function, pick two values. If I pick something on the right side, increasing function there. Let me go fix that. Make this an increasing function. There we go. If I pick a right point, there we go. That's an increasing function. This is going to be an overestimate. We have too much above the line that's being shaded in, so it's an overestimate. So this will be an overestimate. That's probably just worth 1 point on the AP. Alright, so let's take a look at part D. It says the density of bacteria in the petri dish can be modeled by this function, G of R, or as I like to say, like a pirate, grrr. Alright, is given by this. Now that's an ugly function, and we have to type that in our calculator. They make it ugly on purpose. They do not want you to do this by hand. For what values of K is G of K equal to the average value of G of R? So the first thing we have to do, we have to find our average value. It's our fave. 1 to 4 minus 1 from 1 to 4 of this equation. 2 minus 16 cosine 1.57 root r, and let's see here, this cosine bit, oh, this is nasty, is being cubed dr. Alright, so we're going to type this in our calculator real quickly, and this is a tough one to type in, so let's go ahead and do this. Ready? Menu 4.3, I'm using the CAS, the CX does the same thing. We'll go from 1 to 4. Oh, let me see if I can get this look a little bit better there. Alright, let's see here. There we go, 1 to 4. And when I type this in, it's going to be 2 minus 16 cosine. All right, now I need that cosine in another parenthesis too. That's how crazy this one is. Cosine 1.57, the square root of x. All right, go out here. That's going to close my inside. And let's see here, 1, 2. And I am going to cube this. So make sure I got this right. Closes that one, closes that. Dx. Press enter. It's ugly. I'm going to divide that by 3 to get my average value. And that gives me an average value of 9.87. Now I'm going to go a little bit further. So it's 9.8758 right there. All right, now that's only part of it. That's hard to type in. We want to find out where the function, where g of k, g of k equals the average. So basically they want to say, okay, find this function. Where does 2 minus 16 cosine 1.57 root r cubed equal 9.8758? And if I graph this, I put this in as y1 and this as y2, and I just graphed them. So if I go back to my calculator, all right, I'm going to graph the first one. 2 minus 16 cosine 1. Whoops, need that in parentheses again. I always keep forgetting that. 1.57 root x, even though I use r, cubed, caret 3, enter. There it is. And next I want to graph 9.878, but my graph doesn't go that far, so I'm going to change my window. I want to be able to see it. So, sorry, window. There. Come on, you like me. Window settings. I might make this Y max, maybe 12, so I can see it. There it is. All right, so now I'm going to graph that. Graph the other one. Tab. And I'm going to graph 9.8758. Now, it has two answers. That's not cool. Yeah, sorry about that. We have two answers, but we're only going to pick the one because of our domain restriction here. And so, let me see here. Analyze graph. I'm looking for the intersection. Upper bound. Oh, I guess I would hit lower bound. There we go. And I get this 2.497, and that's what we're going to use. So we would say R, or in this case K, I guess, of the AP will be okay with that, is 2.497. And there's our answer. Whew, tough one. All right, come back, we'll take a look at part 2. I'll see you then.